but that's hard to prove. All right, so let's talk about the physiology of it. So you have the baby, the zygote. Zygote's after the sperm is produced and the egg is produced, and along the way, magic happens, and the baby is formed. Okay? The zygote's single cell, but it quickly begins to do mitosis and divide into more cells. Now, sometimes the cells don't stick together, and what happens?
Nothing.
You have a twin.
Oh.
Yeah. Okay. So if that first division doesn't stick, now you have identical twins. Fraternal twins are when the mom produces 2 eggs, and they both get fertilized. Okay? So those, even though they are developing in the uterus together, they are no different than non-identical siblings. They just happen to be being cooked together. Yeah. And if the cells then fuse back together after twins are formed,
Identical?
Siamese twins, okay, where they're attached, which usually can be unattached, but it depends on where they attach and what they share. Sometimes they share spinal cord, sometimes they share major organs, the head, yeah. Yep, that can happen. With epigenetics, we also have certain, well, not epigenetics, but it's sort of part of the epigenetic system. Some genes, they call them junk genes, which I think is a bad term for them, but somewhere around, I think, like 20% of genes, their only purpose is to regulate other genes, which again is a whole nother layer of complexity. So you have certain genes that determine what other genes are doing and how they're functioning. Okay? And then you have the epigenetics on top of that. So this is why we cannot create super designer babies. I mean, we can do a few things to create a designer baby. We'll talk about some of the genetic testing that you can do. But you could do, like, if you're having in vitro fertilization, so you can fertilize a bunch of eggs and then outside of your body, and then you can do genetic testing and determine, like, what their hair color is, what the sex is.
Can you take out bad genes like cancer and like that?
We can't do that yet, although that's something that's being researched. So there is definitely the potential for that, yeah. You could potentially fix like Down syndrome, which is an extra chromosome. So so there is a potential.
Or not. Who knows?
Or not, yeah. You could create other problems. Yeah. That's sort of your, and then you're getting, what was that?
You want to take it with a grain of salt.
Take it with a grain of salt, yeah. And now you're potentially causing other DNA damage. I mean, we've all watched Jurassic Park, right? You know what happens when you mess with DNA.
Yeah, do you know if diabetes is mostly genetic or?
Diabetes is strongly genetic. Now, just like everything else in genetics gives you the potential for diabetes. So you have an increased potential to get it. If you live a healthy life, you may never get it, even though you've got crazy genes for it. But if you've got a lot of people in your family with diabetes, then you need to be really careful. Whereas if you don't have a person in your family with diabetes, you could probably eat crap all your life and be okay. Yeah.
Like with my family, we have like a history of kidney failure, but it's mainly on my dad's side, but everybody has gotten it. So I know that since I was a kid, I had to do a special type of tea.
Interesting.
And like,
So for your kidneys?
yeah, so like I know at least for that, we have to drink tea every day.
Yeah, so if you have a genetic predisposition for an issue, schizophrenia, genetic. If you have parents who are schizophrenic, then you have a 10% chance, or 10% of children with schizophrenic parents get schizophrenia, which is not really high, but it's still like you don't want schizophrenia. But we know, even though schizophrenia is genetic, that it's usually triggered by a stressful event. So you have to maintain decent stress levels so that you don't turn on those genes. See, that's what you're doing when you're stressed out, is you're turning on a gene that was previously turned off.
Someone I know just got
diagnosed.
with schizophrenia. He's in a facility now, and I'm just like, wow. Ever since him, my friend broke up, he went crazy, and then I don't know what else he went through after that.
Yeah, so it could have triggered schizophrenia. Do you know if it runs in his family?
I don't think so. I'm not too sure.
Yeah. Well, and it's always possible that that gene was being passed down, but it hadn't been triggered in anybody yet.
Oh God, okay, I'm just thinking about all my genes, but psychosis also runs in my family.
Does it?
Like, I know my grandpa had it, my mom had it, 2 of my uncles have it, my sister used to get it, so I know, like, for us, we always have to be extremely open to therapy and always go if we're ever, like, super stressed out.
Yeah. Yeah, mental health most mental health, if not all mental health disorders, have a genetic predisposition. Depression could run in your family. I mean, I'm Irish. If you're Irish, depression runs in your family, it's just guaranteed.
Anxiety.
Yeah, anxiety. So, and what that is you have genes for a hypersensitive nervous system. So it makes you more like anxious about things. So, I mean, it's good to know, if you're adopted, it sort of sucks, but so it's good to know like what your family lineage is, because now you know what you're more predisposed to have. And with genetic testing, some of the genetic testing will tell you about your potential for anxiety and depression, things like that too. Yeah.
How connected is the Scottish DNA to the Irish?
Oh, it's like the cousins who hate each other. Yeah. I'm Irish. I'm not Scottish. It's not the same thing.
Scots Irish. Well, that's what I
because they mix.
Yeah, because there's.
And we always remember environmental factors are influencing these genetics. Right? You can never ignore that.
That's for sure. I look just like my mom, but just don't have a color.
Yeah. Okay, so we talked about how there are single genes that determine certain things. Okay, so your eye color is determined by one gene. But we also have polygenic inheritance, like depression or intelligence, which is determined by many genes. So if we look at single gene inheritance, which is what you usually talk about when you're talking about beginning genetics, then you have dominant and recessive. So brown eyes are dominant, blue eyes are recessive. And dominant, of course, gets expressed. Has anybody seen, what is it called, Punnett squares? Okay, so you had Mendel. Does everybody know who Mendel was with his peas? Yeah. So he was one of the early researchers for figuring out genetics, and he looked at genetics in peas, and he came up with this square idea. So if you have, so you have a mom, then you have a dad. Okay, and let's say dad has brown eyes, we'll say that's capital B because brown is dominant, and mom has blue eyes, and we'll put a little b because it's recessive. Now, if mom has blue eyes, then that means that she has to be double recessive, because if she had a brown-eyed gene, then brown would be expressed. However, dad could be, even though he's brown-eyed, he could have two brown-eyed genes, or he could have a brown eye and a blue eye, because the blue eye doesn't get expressed with the brown eye. So let's say I have blue eyes, and so even though my dad had brown eyes, he had to have had a recessive blue eye gene. Does that make sense?
My grandmother, she had 2 kids with blue eyes, and they were light skin with blue eyes, but 4 of them died from looking tired. She has 4 of them, she has 4 of them.
Yeah.
But living in Haiti,
Yeah.
it happens.
Yeah.
So I just don't know where that comes from. That's why I want to do that.
So somebody's been carrying around a recessive blue eye gene. Yeah. Even though
we have French in my family, so.
Oh, well, there you go. Yeah.
Could it just mutate on its own?
It could mutate on its own. Mutations
That's how
do
it
happen.
happened.
Mutations are generally unhealthy, though. You rarely see a healthy mutation happen, which, by the way, is one of the arguments against evolution. Evolution requires that mutations must have happened, but research shows that the majority of mutations are not beneficial to a species. Like radiation causes mutation, for instance. If you get mutation of your DNA from radiation, you're not going to live very long.
Is that why they tell pregnant women not to stand next to a microwave?
Probably. Yeah, I don't know. I know microwave. Oh yeah, I assume it must cause some level of radiation. I don't know if it could actually cause damage. There's also like interstellar radiation. So if you go on an airplane, you get a certain level of radiation, but it hasn't been shown to damage the development of babies. Unless you're an airline stewardess who's pregnant, and then you're exposed to very high levels of that, and then yes, it causes miscarriage and can increase its chance of genetic disorders. So, but yes, in theory, you could have a positive mutation. It's just very, very unlikely. All right, so the way we do these squares is, okay, dad has a B, capital B, dominant B, mom has blue eyes, and And then because mom has blue eyes, she's got 2 recessives. So you have another chance of dominant, recessive, dominant, recessive. So what color eyes would you get if you were this kid?
Brown eye.
You'd have brown eyes, okay? But you carry a recessive gene for blue, so you could have children with blue eyes. Now you could also, you get a recessive blue from dad, recessive blue from mom. Now what color are your eyes? Blue. Okay, so this is me. I've got blue eyes. I got this. So that means that my children, unless I have babies with a guy who has brown eyes, then my children are guaranteed to all have blue eyes. So if he has blue eyes, all of the children would have blue eyes. And then you have a second chance of blue eyes.
You have 50% chance.
You have 50% chance, yeah. Okay. Now, of course, if dad doesn't carry the genes for blue eyes, if he's what we would call homozygous dominant. So there's heterozygous and homozygous. Hetero means mixed, homo means the same, like homosexual. So now you would have brown and blue, and you would still have brown and blue. So even though mom is blue-eyed, all of your children are going to have brown eyes. Interesting, huh? Because it's dominant.
Yeah. One of my daughters has blue eyes. My other daughter was born with blue eyes, and at 6 months they changed brown. Is that something that's turned on or off? Or?
Yes, yeah. So something epigenetically changed. Yeah. Yeah, a lot of young creatures are born with blue eyes and then they change. Yeah. I'm not sure what causes that either. I'll have to ask about that. Okay, so now it is a little bit more complicated than this. So there's the color, the shade of blue could be different, the shade of brown could be different. Hazel is still a brown gene, but you have like a covariant green gene. So it can sometimes be complicated. You could have multiple dominant genes acting at the same time, which is what you have like with your red blood cell type. So whether you're A positive or negative, you've got double dominances interacting and forming a certain blood type. So this is basic, like beginner level genetics. Just remember, it's always more complicated than what you learn in class. Okay. Does this make sense? Okay. Let's see, we already talked about this. But you could do the same sort of square for sickle cell anemia. So if you're a carrier, so let's talk about that again. So you could have sickle cell anemia, or you could be a carrier of sickle cell anemia. And then there's a chance that you give that to your children because you're carrying the genetics. So you could have, let's say dad has sickle cell anemia, so we have a big S, and mom doesn't, but she's a carrier for it. Now you have a child who has it. Actually, in this case, the child would just have it, period. If dad's homozygous, then kids are going to have it. See, because of this. So if you're a homozygous carrier of that, then your kid is in trouble. But if you may have it, but you have one recessive gene of not having it. Actually, no, I'm sorry, I have it backwards. Not having it is dominant. That's the good thing. So even if dad is homozygous for not having it, then even if mom has sickle cell anemia, your kids will be okay. Does that make sense? I was saying it backwards. So that's the fortunate part of sickle cell anemia, because S would be you don't have it. The lower S would be yes, you do have it. So fortunately, having sickle cell anemia is recessive. Not having it is dominant. So if you have sickle cell anemia, make sure you don't have babies with another person with sickle cell anemia, because then there's a high probability that your kids don't have it. Okay. If both parents carry it, 25% chance.
Now, does that go for like any other diseases?
Yeah, it goes for anything that's genetic. Whether it's a disease or just a phenotype trait or a psychological trait, it's all going to work like this. Now, again, it's more complicated. You can have incomplete dominance, so you could have children that don't have sickle cell anemia, but because they carry the genetics for it, it's still having a slight effect on the child. And that's what we call incomplete dominance. So they may be slightly more sickly than they otherwise would be. They may have episodes of getting sick that sort of mimic sickle cell anemia. So that's the other weird thing, that just because something is recessive does not necessarily mean it's not affecting you. So like hazel eyes, you have a recessive green eye, and that's still going to influence the brown in your iris. Okay, so that's incomplete dominance. Like I said, it's more complicated. So here's some examples of dominant and recessive traits. So dominant, brown eyes, dark hair, non-red hair. Curly hair is more dominant than straight hair. Normal vision, luckily, is more dominant than nearsightedness, although farsightedness is more dominant than normal. A Roman nose, which is a big nose. Broad lips. Extra fingers, how weird is that? That's actually more dominant than having 5 fingers.
Yeah, I saw that on a news story about a family, all of them, mom, dad, and children had 6 digits.
Because if mom and dad both have the genes for it and it's dominant, then kids are guaranteed to get it.
And they never wanted them removed. They said, this is just what we, this is who we are, it's how we're born.
Well, I guess if everybody has it, you just kind of get used to it. Yeah. Double jointed, pigmented skin versus albinism. Type A blood and type B blood are dominant. Normal hearing, luckily, is dominant over deafness. Normal blood cells are dominant over sickle cell. Remember I said that's the lower S, so it's recessive. Huntington's disease, unfortunately, is dominant. So if you have Huntington's disease, you shouldn't have kids. But again, this is a middle age disease. So you've probably already had children by the time you figure out, unless you've done genetic testing, which we'll talk about more later. Cystic fibrosis is recessive. Phenylketonuria, PKU, is recessive. Passage disease, recessive. So most diseases are recessive. There are some, like Huntington's, that are dominant, but the majority are not going to be dominant. Okay? So sort of interesting. These are just a few of the characteristics, but we have thousands of characteristics that are being controlled by
Are those 2 starred?
DNA.
You had cystic fibrosis starred, and the other, I think it was Tay-Sachs, you had starred. Or no, okay, PKU. Why are those starred? And sickle cell? Huntington's disease, you have all those starred. Are those something you find out later?
Probably just because it's a genetic disease.
Okay.
No, because you could be born with cystic fibrosis or PKU.
I just looked up with cystic fibrosis. Oh my god.
Yeah, it's bad. I've got a cousin who was born with that. Yeah. It's a bad thing. Of course, they're living longer nowadays. The medical care for them is a lot better. Used to be if they lived past teenage years, it was a miracle. But now they can live until 20, 30, usually. My cousin, I think, is 35 and he's still alive, so he's doing really good. But his dad is a medical doctor, and he's got like all of the advantages anybody could possibly have with that disease. Yeah. Okay. Now, some of our genetic inheritance is determined by what sex we are. So whether you inherit an XX or an XY. Some diseases are located on an X, some diseases are located on a Y. If it's located on a Y, then only boys can get it. Most sex-related, sex-linked inheritances are on the gene, the X gene, the X chromosome. So if it is sex-linked, then it's usually not the Y, but there are some that are Y-linked, okay? Such as the gender of your baby. That's only on the Y chromosome. Color vision is on the X chromosome, which is why men are more likely to be colorblind. Because if you're a girl and you have color blindness here, then you can read the DNA on the second chromosome and you can pick the normal vision sort of thing. Okay? Yes?
How does it look when people are color weak?
Color weak?
Yeah.
I don't think I've ever heard of color weak.
It sounds like let's say co-dominant.
It could be something like codon.
Yeah, because I know my mom and I are color weak, but we're not completely colorblind.
It could be mild color blindness. I mean, the severity of the color blindness is going to be determined by a different allele, because it's polygenic.
I know when we went to the doctor, he was like, it's because you see colors differently. Like, she can't see the blues.
Interesting. And he doesn't consider that colorblindness?
No, it's not that she can't see it, it's that to her it looks like magenta.
That's interesting. I mean, I would guess that some genetic variant similar to colorblindness. It may not be exactly colorblindness, but it's going to be working in a similar way. And if both of you have it, obviously it's genetic. Well, I mean, it could be environmental, but that would be a weird thing to be environmentally caused. Like every time I said something was blue, I got beaten, and my mom said it was purple. In theory, that could...
That's possible, though, right?
It's possible. But that would be weird. All right, so if you are a man and you only have XY chromosome, then this double sort of like safety mechanism is gone. So if you have the colorblindness gene, now you're guaranteed to have it because you don't have that other leg on the Y chromosome. So this is why men are much more likely to be colorblind than women. There's a lot of other things. Hemophilia, so a genetic propensity towards anemia, reduction, MS. There's a lot of diseases that are related to a particular chromosome. And because men are missing this one leg of the chromosome, men are much more likely to get a genetic disease than girls. So male babies are more likely to die from a genetic defect than a female baby is. Although females are more likely to die later on because we're more fragile than men. Men are more likely to die as babies. So it's sort of an interesting trade-off there. We're all going to die eventually, though, so it's not a big deal. All right, so we have single gene inheritance. I mentioned polygenetic inheritance, things like intelligence suppression. Your height, God bless you, is actually polygenic. It's not simply you have a gene for height. So you can't just like stick in a new allele set for your kid to make sure that they're tall. It is many different areas. So like your bone growth rate, your ligaments, your skin development, all of these things have to work together in order to create a tall person. You can't just say be tall. It doesn't just work that way. The interesting thing is if something is polygenic, we have a normal distribution, which may not be the case with other single inherited things. So a normal distribution is that bell curve, like for intelligence. Most people are in the middle, and then you have the same amount of people dropping off to the extremes. So height works this way. You have an average height. I think right now the average height is 5'7". For a man, if I remember correctly. And 5'9", maybe, I don't know. I'll go with hers, whatever. It's something, there's some average. But the point is that there's a normal distribution. The extreme short, there's significantly less, and that falls off at the same rate that the height, that the extreme tall falls off. So you're going to have as few people at like 3 feet as you would at 7 feet. So anything that is polygenic, it's kind of a weird thing that we have as normal curve distribution. It's one of those weird bits of biological trivia. My grandma's family, her mom was 4'9", I think. And then there's a great family portrait. I need to get a copy of it because I want to put it on my wall. And there's 7 siblings, and they're lined up by height. It goes from 4'9" all the way up to 7'7", I believe.
Wow.
Yeah, isn't that interesting?
7'7".
7'7", yeah. 4'9" to 7'7", almost 3 foot difference between them. How crazy is that? We assume there must have been some sort of like hormonal issue going on in that family, but who knows? But we do have a lot of tall people in my family. All right. So mutations are a significant change in gene structure or arrangement. And like I said, usually they are not good. Now, occasionally you do have beneficial mutations, but the majority of them are harmful. A mutation will produce a new phenotype. On the negative side, you may have a kid who's born with 2 heads, fish with 3 eyes. If you look at like Chernobyl, right? Everybody know what Chernobyl is? Not the horror movie. Who does not know what Chernobyl is? Oh my goodness, what do high schools teach? Never mind, don't even answer that. I know they don't teach crap. Barring you. Do you teach high school?
No, middle school, 8.
Middle school? Teach them what Chernobyl is, okay?
I'm not allowed to. I have a certain
Really?
curriculum I must attend
Well,
to.
mention it in passing. See, that's what I do to try to
Sneak
get
it
you
in there, huh?
educated. Yeah, I sneak it in there. Chernobyl is definitely not part of the developmental psychology curriculum. But let's see. Greenpeace has a good video on it. Okay, so Chernobyl happened in 1986. Yeah. And this was in the Ukraine, and this was a... And then it gets into all the Greenpeace stuff. So, so Chernobyl, bad nuclear disaster. Although they say that Fukushima over in Japan has released about as much radiation, which, by the way, is still melting down all these years later. Still releasing radiation into the ocean. The news likes to downplay that, or not even mention it at all, but it is still in the process of melting down.
In the ocean?
Yeah, because Fukushima, a lot of nuclear plants, most are on the ocean, so that they can use the ocean water to cool down the reactors, because if they get too hot, they'll melt down. And that's what happened in Japan because of the earthquake. They couldn't get the water to go in to cool it down. So now, I mean, before it wasn't, when it went through, it didn't bring radiation back out, but now they're broken, so it's bringing radiation out. So it's constantly leaking a huge quantity of radiation into the ocean.
How far does that
Daily.
spread?
24 hours a day. Depends on who you ask. The government says it doesn't spread very far. A friend of mine does deep sea fishing, and they Geiger count every fish that they catch to check the radiation in the fish.
And what do we find?
And depending on the variety, some fish are more susceptible to storing the radiation, but she's found radiation in many of the fish.
In what area? Pacific coast?
Yeah, off the coast. Yeah, she lives in the high desert, so she goes fishing.
Really?
I'm not sure where, but yeah.
Oh, yeah.
Out in the Pacific.
So that's why they're saying the ocean isn't as safe to swim in?
Yeah. I mean, that's one of the many toxins we have dumped into the ocean, but yeah, it's definitely one of the more significant ones. Yeah. All right. So anyhow, long story short, that's a mutation. Mutations are almost always bad. There are rare times when mutations have been beneficial, but it's super rare. And obviously, if it's caused by radiation, chances are it's really bad. Now, the interesting thing is once your DNA has been mutated, it is now something that can be passed down to your children. So if that's a beneficial mutation, great. If it's a bad mutation, sucks for your kids. So all those people living in the Ukraine area who are still being exposed by that radiation to this day, they could be passing down a lot of health problems to their children.
As we saw by the Siamese twins.
Yeah.
That were on that video.
Mm-hmm. And you saw the cleft palate too. That's another genetic mutation. All right, so other chromosomal abnormalities, you've got all sorts of genetic issues, Down syndrome being the most famous and probably the most common. Down syndrome is also called trisomy 21 because it is the 21st chromosome where there are 3 of them. There's an extra chromosome, and that's what causes the Down syndrome. So Down syndrome includes mental retardation. Of course, there is a classic physical appearance to Down syndrome. Nowadays, people with Down syndrome are actually living pretty long. It used to be, 20 or even less was the average age, mostly because of heart issues. But if they are living in a wealthier country that has good medical system, then they're living a very long age. And even though they suffer from mental retardation, it's not extremely severe mental retardation. They can still function really well. As a matter of fact, I like showing a video about that. I'm a video person.
Yeah, I like your videos.
Yeah. Let's see. Maybe interview. Let's see if I can find one. Okay, this is a decent one.
Because you never know what might come out of the house. Like, what is Down syndrome fella saying? What makes you angry?
Smoking. Nigel Farage.
You don't like him?
That's right.
People with Down syndrome can't have relationships.
Well, obviously they can have a relationship.
Kissing is my favourite pastime.
So you're really romantic. Oh, so romantic, yeah.
I like to give hanging out of the at Justin Bieber. Not in covenant.
People with Down syndrome can't learn. Yeah. Alright then.
Yes, they can. Maybe sometimes they might need a little bit of a push.
Yeah.
I've got qualification customer service, qualification in hairdressing. I passed all 10 of my GCSEs. If with that syndrome, I just know people.
Yeah, will she be able to do this? Will she be able to do that? And I think, yeah, she'll be able to do everything. It's just we'll take the scenic route. This is our pet hate. Adults with Down syndrome are like children.
Oh.
Do you ever have people like come up to you and talk to you like you're a child?
Yes, it's patronising.
Yeah.
But some people do the head tilt as well. Oh, bless her.
Yeah, she has Down syndrome.
Lovely. How old is she?
Infantilisation, do one. Yes, please.
Some people say it's a disease. It's not.
No.
Asperger's is a condition which is caused by an extra chromosome. Doesn't stop you from doing anything, does it?
Well, exactly.
We're bringing something different to the world that other people can't.
People sometimes do come up with words like Down syndrome sufferer. The only thing I suffer from is bad attitudes.
Those with Down syndrome can't live independently. I hope not.
Of course they can, but I live independently.
Hopefully wanting to live with my boyfriend.
Wouldn't mind living somewhere with my girlfriend as well.
And have a life, and go out with friends, and having a nightlife as well.
I get my sweet back if you move out.
So you're going to move out today?
No.
Those with Down syndrome can't have jobs.
Well, that's wrong.
Of course they can. Of course they can.
Yeah.
I've had so many different jobs.
I work in a house salon and I love it.
Yeah.
Went through retail, office work, went back to retail, then went back to office work, and then media.
I'm also an actor as well.
I got a job as an actor and a dancer. You're famous one day, Tommy.
Yeah, well, even more.
One day might be putting his fingers.
But she can be anything she wants to be. Well, unless she wants to play for Liverpool, in which case.
It's quite upsetting to hear about something like that.
But it was 90% of people were getting rid of it because they found out they were Down syndrome, and I thought, that's shocking.
Some people call this syndrome serious handicaps, but it's not.
Babies with Down syndrome can be aborted at 40 weeks.
I've heard of that.
Whereas a baby without Down syndrome, obviously the cut-off point is 24 weeks, so I think there's an ethical question there.
But we can all lead amazingly active lives, can't we?
Yeah.
She doesn't like the
Do you wish you didn't have Down syndrome?
No. Why? It's just me, it's part of me.
I may have Down syndrome, but without it, I don't think I'd really be me. I don't wish that. I wish that people will see Down syndrome in their positive light. My motto in life is Down syndrome, so what?